Dr. Christensen. She's presently a senior lecturer in the Department of Computer Science in the University of Sheffield, UK. This department is internationally known for the quality of its research and is in the top of the computer science department in UK. She's also a member of the Center for Assistive Technology and Connected Healthcare, and she's also part of the Speech and Hearing Research Group in the department or in the University of Sheffield. She's also a theme lead for the UK RI Center for Doctoral Training in Speech and Language Technologies and their applications. Also, she's the technical lead for CognoSpeak. This is a speech-based tool for detecting and tracking signs of cognitive impairment. And finally, she's a member of the IEEE Speech and Language Processing Technical Committee, associate editor for the IEEE Signal Processing Letters, member of the organizing committee of the Automatic Speech Recognition and Understanding this year, and InterSpeech, and also area chair of InterSpeech 2021. So what about her research? She has a PhD from Aalborg University in Denmark from 2002, and she joined the Speech and Hearing Group in Sheffield in 2000. She has led numerous projects, European and also UK funded, and presently she leads a team of perhaps 10 researchers. I think the team is growing very fast, and she works on the application of speech and audio technology in healthcare, which is a very challenging field with a great potential for translational research and with real impact for people. This area of work is we have seen huge advances in mainstream speech recognition and understanding. This is clear, but this is not directly applicable to the healthcare domain because first we have challenges from the need to have a personalized technology tailored to the individual's impairments, and then also the lack of available data, which is data to train the computational models. No? So her research responds to these challenges in two areas: automatic recognition of disorder and atypical speech, and detection and tracking of verbal and nonverbal traits in speech and language. And while she's taking part on many projects, she participates in the training network TAPAS, which is funded by Horizon 2020. She's also been working in the very known home service project, which was, I think, a very long project, providing speech-driven control systems for people with speech disorders and also for older people. And well, she also participates or leads the project COMPASS, computational assessment of stroke survivors. And also they brought the CognoSpeak project or tool to Kenya. And I think because of that, they have a Google researcher work, Deep Art. And well, also, apart from that, if this is not enough, Heidi Christensen is very active in the faculty in work to ensure more women in STEMs, and she's recently featured on the University Wall of Women. She's currently faculty director for equality, diversity, and inclusion, and member of the diversity committee of ISCA. And well, finally, I would like to use her own words, which I have extracted from one interview, where she says that she's interested in the use of speech technology to help people in general, and especially people with serious handicaps who find it difficult to use their hands. And this is a very rewarding research, working with real people, but it's also very challenging and very interesting. So it is my pleasure to let the word to Heidi, and I am sure she's going to explain us this very well, and she's giving a very, very interesting talk. So Heidi, your turn.
Thank you so much. Thank you very much for that very comprehensive introduction. I will share my slides now. Thank you very much for inviting me, Inma and Herman. I'm really excited about being here today. So as Inma said, I'm a senior lecturer in the speech and hearing group in Sheffield. Can you see my slides? Yes, I think you can. So in case you haven't been to Sheffield, I just thought I would put a big star on the UK map for you to see where it is. So it's sort of more or less in the middle of England, close to Manchester. And to the west of Sheffield, we've got this very, very beautiful Peak District National Park. But Sheffield itself is perhaps slightly less pretty. We've got a very nice teaching building, which is the one with the diamond shapes here. But otherwise, on normal years, I reside in the building in the top left-hand corner there, Regent Court. So as Inma said, it's a very large speech group we have, and with the NLP group, we span one of the largest hubs of speech and text processing in the UK. And in the speech and hearing group, we kind of span research from covering computational modeling of auditory and speech perceptions to normal kind of robustness in speech recognition. You might know Professor Thomas Haynes' work in this. And then to my work on one side on kind of healthcare applications of speech technology. And as Inma said, I became a lecturer about 6 years ago now and have been growing a team of PhD students and postdocs to try and tackle this area. And I will talk to you in general about how we can use technology to improve the lives of people with pathological speech. So that's my kind of key research interest. I thought it might be useful just to start with a bit of a definition of what pathological speech is. So it's defined as a communication disorder where your normal, or we prefer to use the word typical, speech is disrupted. And there's lots of reasons why you might have pathological speech. Cerebral palsy is one of them, and we work a lot with users with cerebral palsy. Stroke is another one. And of course, general cognitive impairment, such as dementia. So why is it we think as engineers and computer scientists that automation has got anything to offer here? What is it that automation can kind of contribute? And I think there are three main kind of areas. So often automation means that we can do tasks faster, which often means that they're also cheaper. They're more repeatable and also often very objective if you can take some of the human out of the loop. Computers in general can kind of complement the analysis that humans might do in routine care. But with all of the work we do, we're very careful to make sure that everyone understands that we are very mostly not interested in replacing the human. So for example, the doctor, but we are interested in adding to the care that they can provide, if you like. And so the third point really is the sort of ability to augment or improve the healthcare provision, which means that you can get access to more data points and help people more outside of these usual face-to-face meetings. So certainly in the UK, but I think across the world really, there is a constant struggle to have healthcare funded enough. So that's where we can see automation really helping. So I'm going to, we do a lot of different things in my group. I'm going to concentrate on two main things really. So one is improving the communication ability for people with atypical or dysarthric speech. And then the other one is detecting pathologies in a person's speech and language, in particular dementia. I'm going to concentrate on here. So why is it we might be interested in kind of improving a person's communication ability? So people with atypical or dysarthric speech, often caused by long-term conditions like cerebral palsy or stroke, they find it hard to communicate effectively with other humans, but certainly also with machines. So often their close family might be able to understand what they're saying, and I'll show you an example, play you an example in a minute. But if you haven't met them before, you might struggle yourself. So this means if they can't use speech technology, they're really cut off. And of course now speech technology is becoming ever more pervasive. So I'm really interested in closing the gap to enable them to make use of all of this. And in addition, if they have things like cerebral palsy, they will often have mobility problems. So they couldn't easily access computer technology or smartphones, etc., by using a keyboard or a mouse or a trackpad. So they kind of, there's a bit of a double whammy. They can't speak to their technology and they can't sort of use other ways of interacting with it either. If we can fix some of this for them, the impact is for life. So for me, that's really, really important. If you give a small child with cerebral palsy a communication aid when they're 5 or something, that's with them forever. So the potential impact is huge. So what are the sort of example applications? So obviously speech recognition for text input, dictation, being able to dictate an email or an SMS or message or anything like that is a huge step change for people like this. Of course, you can use speech recognition for controlling your smart home devices through Alexa or something else. Or you might use speech recognition in a general sense for a communication aid. Lots of people are exploring voice input, voice output technology. So they would use their own voice to input the speech, and the technology would then sort of translate it into spoken language that could be more generally understood. And just briefly about cerebral palsy. So this is caused by birth, problems at birth. Currently affects about 3.5 per 1,000 live births. I'm guessing this is a UK statistic, I don't quite remember, but it will be a similar statistic across the developed world. And it's one of those where actually these days you see more incidents because medical advances means that we can save more early born babies. So it's definitely a problem that's there to stay, if you like. And the problems they have in terms of their speech and language is they've got problems moving their articulators. So it causes slurred speech, unclear speech. They have to slow down the speaking rate often. And they often also can't express all of the vowels as clearly as people with typical speech. Yeah. Oh, I should say, so I'm just going to play this video for you twice. First of all, I won't let you know what he's saying, so just listen carefully.
Yeah. Did you understand what I just said? It's easier for me to talk than it is to type. So the idea was initially that we can talk to instead of typing into.
So this is John, who is a user in our Catch Center. We've been working with him for 10, 15 years, and he's got what you would say moderate to severe dysarthria. And this is him speaking as clearly as he possibly can. Now, I've heard this clip maybe 50 times, and I just about understand it now, but I'm guessing you would all have struggled to understand much of what he's saying. But I'm going to play to you again, and this time with captions, and then you can see that he is actually saying all of the words. They're just sounding very, very different from a native English speaker with typical speech.
it's easier for me to talk than it is to type. So the idea was eventually that we could talking instead of typing into.
So John here is a very good example. He has no cognitive problems, so his brain, apart from being able to speak and control his body, works completely normally. So he, last time I saw him, was busy taking a degree in philosophy. And of course, as you can imagine, he then needs to write very, very long essays. And I've seen him type, he types one letter at a time, and it takes a long, long time. So for him to be able to use speech recognition would be completely life-changing. So what is the issue with dysauthentic speech? So I've just got a couple of slides outlining this. So this is from a paper presenting one of the very few databases available. And you can see at the top a plot comparing people with dysarthria, that's the red blobs, and people without, and the duration of the vowels. And you probably can't see the details, but you can see in general all of the vowels are lasting longer. And for those of you who work in speech recognition, you know that that is a complete disaster. Because the speech recognizer will have quite well-learned models of how long a typical vowel is. And likewise at the bottom, this is the plot for consonants. Again, they're much, much longer than typical speech. And then this is another plot from the same, or a different paper, but on the same database, showing just the kind of vowel space and the variation in the frequencies you might experience. So you can see with the dysarthric male at the top, the variety within that one male is huge. So the different vowels just sound quite different every time they say them. So you have some variability with typical speakers as well, as you can see at the bottom plot, but they're nowhere near the top. So if you're trying to learn a model that can distinguish the vowels at the top, you can see that the circles are very, very much on top of each other. So that's a huge problem for ASR, for speech recognition. So just to summarize what the kind of challenges are if you want to recognize this, basically this speech that we have from dysarthric speakers is too far from those acoustic models we've trained on typical speech. So we really need to do something to narrow that gap. It's really, really difficult for us to get enough data, and it's difficult for the speakers to really produce enough distinguishable phonetic tokens. And then as you saw, there's the sort of lack of consistency of articulatory patterns, which is much higher than for typical speakers. So all of these three things just make it really difficult to get speech recognition to work well. I just want to show you this plot here of what sort of happened in the development of mainstream or typical ASR. So going back to 1970, 50 years ago, you had sort of simple command and control system. You said one word at a time. But quickly you were able to sort of dictate things, and we were able to have automatic response systems in call centers. And recently, of course, we've had systems like Alexa and OK Google and those kind of systems. And recently, you know, it's possible to interact with robots, virtual agents, etc. So things have progressed really well. Now, dysarthric speech recognition is still way, way back in time. So we're still really struggling to even be able to recognize phrases, not just isolated words. So what are the solutions? It's the same solutions really that made things work for typical ASR. You need to work on the acoustic models, you need to work on the way things are pronounced, you need to work on the language models. You need to be able to explore all of the kind of deep learning and general machine learning that has been used for mainstream ASR, and particularly look at those approaches that we know exist for sparse data techniques. And end-to-end, if some of you are working in this area, will also perhaps be a solution. So one of the things that is kind of happening at the moment is trying to change the data we have. So there are some companies moving into this space, which is great. So Google has got a big project called the Euphonia project, where they're trying to ask people with speech impairments to donate speech. Sadly, of course, I doubt they will be able to share this, so us in the research community will not get access to this. Another thing you can do is use out-of-domain data, so use typical speech data to try and see if there are ways you can kind of boost recognition for dysarthric speakers. And you can explore, in general, better ways of modeling things and encoding things. And I'll go through a couple of examples of work we've done, but these are just snapshots. So if you're interested, definitely get in touch and check out our web pages, etc. I'll start with home service that Inma mentioned. It is now pretty old. I was still a postdoc when I was working on this. But one of the things that is still relevant from this is that it was one of the first systems to have the speech recognition working in the cloud, if you like. And also this idea that you give the system to the user and then you record the data as they use the system and try and feed that back into the model. So it will sort of improve over time. And we did get very good results on the users we had. But it was a very limited task. So they had maybe 30 different words. So it's not really enabling you to write a 5,000 word essay or anything like that. But it's a start. So some of the things we've looked at since then is, for example, whether we could find different ways of encoding the speech. So traditionally in speech recognition, as many of you will know, things like MFCCs have been around forever and they seem to work really well, but it's not a complete given that these will work for this very variable speech that you get from dysarthric speakers. So we had a student look at what you might do with a more articulatory based approach. And of course, the problem there becomes that you don't have all of these recordings of articulatory information. So we were looking at other ways that you can synthesize this information. And we did find that we could get some improvements on one of the kind of big databases in this, well, not big databases, small databases, but one of the few available databases called UA Speech. Another thing we've tried to look at is whether we could take the dysarthric speech and try and morph it or convert it into something that sounds more like typical speech. And if you were able to do that, then you could start using all of the mainstream typical speech signals. So for example, perhaps you could speak to a little box that would then re-speak your speech. And I know there is a company now called VoiceIt that is trialing this. So trying to process your speech really. And this works to some degree, especially if you're not severe, as you can imagine. And one of the things we tried in this paper here was to see if we could adjust the tempo. So we know people with dysarthria will speak slower because they struggle to quickly move their articulators. And so we were trying to see if we could automatically learn to speed things up. And this does work, although as with many of these things, there's always a risk of you making things worse for some vowels. In general, what you're really wanting to do is to try and take models from trained on typical speakers and see if you can somehow tailor them or adapt them to match speakers with dysarthria. So if you're working in deep learning and neural network space, the key thing here is to do transfer learning. So to try and adapt these deep learning models towards this target speaker. And the problem is that you just typically will have very, very little speech from this target speaker. So this paper here was looking at trying to see if there are ways that we could use other dysarthric speakers, perhaps as a sort of help to train this model, or perhaps non-dysarthric speakers. And we did see that this was possible, but you have to be really careful in how you select these other people. So for those of you who work in typical speech recognition, you will know that you could perhaps have a speech recognition corpus with 100 speakers, and you could train a big nice model using all of these 100 speakers, and the more speakers, the better. That's not the case for dysarthric speech. Some of them will be disastrous to include in a model for particular people because they're each very, very different. So this paper here was looking at how can we, in an intelligent way, pick the sentences from speakers that are similar enough to help the model. And we did this based on interview distribution of the DNN. So it's quite a neat paper in this space. So now I have a student on the TAPS network actually that Inma mentioned that is looking at moving towards this continuous dysarthric speech recognition. And the problem here is that there's very, very little data. So Torgo that we saw the plots from before is one of the few ones, but there's a big problem with Torgo, and it is that all of the speakers were asked to say the same sentences. And so what happens when you train this language model on these sentences is that it becomes incredibly good at recognizing these particular sentences, but it doesn't generalize well. And so you are getting these kind of unfairly, very optimistic, very high recognition results where you know that that is really because the language model just knew things too well. So this work here, this paper, she tried to see if we could make the language model a little bit more fair and include knowledge from a large corpus called LibreSpeech of read audiobooks. So obviously when you make the language model a little bit more fair, it also becomes a little bit less good for this particular. So the results kind of went down, but that's what we wanted. We wanted a more fair framework, if you like. So she's published her setup, and she did a lot of work on that. So if you're working with this database, do check this out. And another thing she tried was to see if we could try and train bottleneck features from autoencoders to improve the recognition as well. So this diagram here is a bit complicated to kind of go through, but the idea really is here that you again use a big database. Here we use LibreSpeech as well to train up this really nice encoding, and then you see how you can combine those features with typical normal speech features to really improve your speech recognition performance. And again, that was possible with a bit of sort of clever regularization to make sure that you train things in an optimal way. So that was sort of the core ASR work. I had another student, which I'll quickly mention her work. So she was interested in this idea of a speech communication aid. And she was interested in seeing whether we could not just recognize what's been said, the kind of linguistic message, but also how things were said. In particular, what emotions people with dysarthria were trying to convey. And I think this video, let me just see. Yeah. I keep forgetting every time I play this to actually look up what she said, but this lady here has also worked with us probably 15 years, I think. And she was very excited to come in and help with this and come in and record this. So were asked to do lots of different sentences with different acted emotions. And my student then did a lot of work on trying to see to what degree can we recognize emotions in the speech, both using machines and using human ears, if you like. And she found that these people are able to express their emotions in their speech, which is really good. And we are able to pick this up with the classifier. So again, really promising for future work. And that was what I wanted to kind of quickly go through on the dysarthric ASR side of things. And I want to now move on to talking about detecting signs of pathology in a person's speech and language, in particular dementia, which is a growing problem in the world. So the motivation here is that people with cognitive impairments, so for example, as a result of Alzheimer's disease or Parkinson's or stroke, they often show early signs of the condition in their speech and language. And if there is a way for us to automatically pick this up, we can improve treatment. There isn't a lot of treatment at the moment. Hopefully that will change, but there is some. And it's also really important for families to know early on what's coming. So dementia is, you eventually die of dementia. It's a deadly progressive disease. So what sort of applications do we have here? So for certain conditions, you can certainly imagine screening them. You wouldn't do that for dementia, but you could imagine other things you might screen for. You could stratify, so decide on treatment of people with memory concerns, and I'll talk about that a little bit more. Or you can do things like track people with conditions like mild cognitive impairment to try and detect whether things get worse. So people with mild cognitive impairment have a 50% chance of converting, as it's called, into Alzheimer's disease. So once you're diagnosed with MCI, that's a very worrying time because you're every year thinking, gosh, have I gotten a little bit worse? And so if you had an easy to use way of measuring whether things went a bit worse, that would be very helpful for them. So just briefly what dementia is, it's a degenerative condition. It's a sort of umbrella term that describes lots of different symptoms. It affects memory. Most people know this, the way you think, your language, but also your ability to carry out daily activities, driving, finding your way around the house and in your city, etc. And Alzheimer's disease is by far the biggest of these, so it accounts for 70% of cases. And it's a growing condition as people live longer. That's the main problem. You have more and more cases, and it's currently the leading cause of death in England and Wales, so higher than heart disease, higher than cancer. So it's pretty big concern. There is no cure, but we know there are a lot of risk factors: age, genetics, smoking, diets, etc., etc. In terms of speech and language, we know that the voice is affected, so the quality of your voice box is affected, but also your language. So you'll start using more empty phrases, less specific words. So it's not like you can't carry on a conversation, but you might sometimes be struggling to kind of find the right words. And there has been some really interesting research looking at famous people who develop dementia. So Iris Murdoch is a very famous English author, writing really beautiful novels, but people have researched her novels through the time and found in her later books that she had a clear sort of reduced complexity of her words, of her sentences, etc. And I heard someone describe a review or a critic of one of her last novels, and where they basically said, oh, this sounds like a 12-year-old has written it. So she clearly had deteriorated in her language. And one of the other very famous examples is Ronald Reagan, who was diagnosed with Alzheimer's, I think about 5 years after he left office. And people have looked at his press conferences, where of course he's not reading a speech, but he's talking freely. And again, they found that he had an increase in conversational fillers, and those kind of things, and used more non-specific nouns over time. So what are the current diagnostic processes? So there's a whole range of things you do when you go to the doctor with memory problems, but one of the things you will incur across most of the world is this test here, the MOCA test. This has recently become a bit famous. This was the test that Trump was asked to do, and that he said he aced the test. And you can see here that he was asked about the different animals. So it's not a difficult test if you don't have any cognitive problems. It's very straightforward. But once you start having cognitive problems, it becomes really difficult. Other things we use are picture description tasks. I'll show you an example of this. But then also the doctors like to use sort of more invasive or expensive procedures like scans or testing your spinal fluids. And then a large part of the diagnosis is also what's called a history-taking conversation. So the doctor will talk with you and your family about your daily life. So why is this important? Well, these current methods that don't actually work very well, they're not very accurate. So a lot of people that go to the doctor will be referred to the memory clinic when really they didn't have any problems with that was caused by dementia. So this caused a lot of waiting and a lot of worry, and it's also really expensive. So each assessment can cost up to £1,000. And I think these days the pound is about the same as the euro, so that's about €1,000. So that's really expensive. And obviously we're interested in reducing that cost. And also the opposite problem is you might go to the doctor because you're worried about your memory. But if you are what's called a high functioning patient, so you might have a good education, be very articulate, it takes a long time actually before this gets diagnosed, because the doctor will, you pass all their tests, you're doing well enough on their test not to get kind of referred on. So what generally the automatic approaches are trying is either try and automate some of the existing tests or try and invent a new test that has additional advantages. So one of the traditional tests is this picture description task. You can see the time. I'll try and speed up a little bit now, where you ask the user to describe all of the things you can see in this picture here. And we've done quite a lot of work on trying to automatically process the kind of picture description. As you can imagine, if you had to do this by hand, you first had to write down everything that's said and then go through and look at the sort of nouns, etc. So one of the things we see here, for example, is a patient with dementia might not realize that the mum here is, or sorry, the lady here is the mum of the children. I think also these days there's some discussion about whether this is at all an appropriate picture, given it's pretty gender typical, isn't it? But anyway, that's beside the point here. I will skip all this on here. So one of the things we did, without going into too much detail, is to try and not just extract the sort of typical speech and acoustic and linguistic features, but also look at how would a neurophysiologist who was trying to analyze this picture description by hand, what would they be doing? And we try to set up this hierarchical neural network that would kind of look at different levels, look at the word level, look at the sentence level, and look at the whole paragraph, trying to mimic a bit what the professionals are doing in this space. But what we're really interested in is kind of analyzing people's conversational abilities. And this came out of, so I work closely with neurologists at the local hospital, where they recorded initially conversations between the doctor, a human doctor, and patients. And we've since developed this digital doctor, or the CognoSpeak system, where we mimic this sort of conversation and record answers to some of these very general questions. So these are all what you would consider quite friendly questions. You know, tell me about, you know, what did you do over the weekend? What's been in the news, etc. So the idea is to have people relax. They might be able to do the test at home, but still the questions are designed so that you can detect whether there are any problems. And this is a system we've developed that we are currently testing in our local memory clinic with doctors. And these are, I won't go into details with this, but just some of the initial work we've been doing on this, trying to, again, see what the humans would do in this situation, what sort of things would they pick up in these conversations, and how do we translate that into something we can do automatically. So I've been very, very lucky to work closely with the clinicians and really try and be inspired by all of the things they do, and as opposed to just thinking in terms of what engineering solution can we bring to this. And we have had very, very promising results. So and one of the things we've been very lucky with is we've been able to record people who have some of the more difficult conditions that are sort of not clearly dementia or Alzheimer's disease and not clearly healthy. But for example, the mild cognitive impairment in between, or people who have anxiety, for example, that might cause memory problems. And that, of course, makes the machine learning much more challenging, and it's more difficult to get good results. But that's also the distinctions that, in terms of the clinical aspects, are the more important ones. And one of the things that we know are difficult when you move outside of the sort of very easy to work with data sets is that we know that something like depression and anxiety also impairs on cognitive impairment. So they have got very overlapping symptoms, and it makes it difficult for humans, so for the doctors to diagnose properly. And of course, it sort of makes it difficult in terms of machine learning. So ideally, you want to know both the level of depression and anxiety and their cognitive impairment to kind of set things up well in terms of machine learning. So we've done some early work on trying to see whether knowing the depression and anxiety levels can help us better recognize different cognitive impairment classes, and that's been the case. You have to be a little bit careful with the data, as always. This was done on a relatively small data set, but we're hoping to be able to repeat this soon. And then, as in Masset, this is a couple of years now, we took the digital doctor to Kenya, the CognoSpeak system. So we're really interested in making sure that this system can be used by people across the world, not just by native speakers in England. And the other group of people we're working with is ethnic minorities in Sheffield, who are more reluctant to go and see their doctor. Of course, they also get dementia. So it's really important that we use a system like CognoSpeak to, in a way that kind of works for them as a population. And dementia is a growing problem everywhere in the world, not just in the developing world. But of course, in Africa, there is an affluent middle class and upper class who has access to good medical healthcare, And so, of course, will live longer. And when you live longer, you increase your risk of dementia. So this is a massive problem. And in a country like Kenya, they really have very, very few trained neurologists. So they have a population of about 52 million. And apparently there are, when we visited, 17 neurologists, and we've got 3 of them on this picture here. So it's a huge problem, and they could really do for having access to something like Cognospeak, which would be a sort of cheap, easy to use diagnostic aid. Of course, there are many, many challenges. People in Kenya and our local ethnic minorities may not speak English as their first language, or they might have a very strong accent. And so how do you use a system that's based on language when it's not your native language? And of course, you have to make sure that everything is culturally appropriate. We tried to introduce a Black digital doctor in Kenya, but for example, things like this picture description task is clearly white people in a very Western-looking kitchen, again, totally inappropriate if you went to Kenya. So you have to think about all of these things to really make sure that your experiments are kind of set up as well as possible.
Jambo.
Oh,
mimi ni daktari wa kompyuta aliyepangwa na nitakuuliza maswali leo.
I've got that video, but that's the digital doctor speaking Swahili. And that's the end of the talk, but I wanted to just quickly finish with a few tips if some of you are considering moving into healthcare. So some of the things I've learned as an engineer in this field is to make sure that what you develop is useful and usable. You really have to work with people and speak to people. You have to work with the clinicians, the doctors, and also with your end users, so the carers, the patients, etc. We've spent a long time in these co-design workshops, really getting their feedback on some of our ideas. And again, the engineering ideas we bring are not always what people want. So we really have to accept that and try and find out what they need and what they work, and repeatedly kind of evaluate our technology. And that's the end of the talk. These are my team. I haven't covered some of the new stuff here, so you can see there's next week, I think it is, Yelin will present her ICAS paper, and we've just had 3 InterSpeech papers accepted. So if you're going to InterSpeech, look out for those. I will stop sharing my slides now. And I think that's time for questions.
Thank you very much, Heidi. Wonderful talk. I am going to share the screen again. I think it's this one, yes. So, well, perhaps it's not necessary to share now the screen. So now it's time for questions. I don't know if there is any. Are there any questions? Otherwise, I have some many questions. Well, your last slide, I've loved it because I think this is very typical that we engineers can. Now I can, sorry, I wasn't able to share the video. So that we engineers can imagine many prototypes and can have very good ideas, but then there is no value, or you realize too late that this is not really useful, or they don't like it, and following this idea, I would like to listen the opinion, because many people with speech impairment, well, many of them have other impairments also, and they may have also speech impairments on one side, but also people with dementia, which are old people. They may usually don't like to work with technology. I found this many times in my own experience, or also in with my family, no? So how do you think that we can cope with this, I think, a very, very big problem?
Yeah, no, you're absolutely right. We try and work quite closely with users when we develop the interfaces, what they look like. But we see again and again, I think one of the things that come up is all people might often be worried about breaking things. I might break the app, or I might break the laptop or the tablet. They might be worried about safety and security, I feel, often, and often, especially, if they read and watch a lot of television, they're generally, if you mention the word AI, they get very worried, and they're thinking, AI is going to take over the world, etc. And it's a big problem, because when you then speak to them and explain, so often, for example, they might, I don't know, be using WhatsApp, or they might be on Facebook with their grandchildren and stuff, and they're very happy about that. Or they might have an Alexa system, and they don't see any problems with this. But of course, those systems, there are also security issues. So often they're using AI without really knowing. So there is a problem of explaining in a way that makes sense and is meaningful to them what's happening and what's not happening. As you say, you have to be really conscious that as an engineer, we don't understand this. We have to speak, and often we speak a completely different language to the doctors and a completely different language to the users. And
okay, we have
yeah.
Yes, we have Laureano. I think you can now switch your micro on.
Okay, yes. Can you hear me?
Yes, very well.
Okay, thank you. Thank you, Makula. Thank you so much, Heidi, for such a great and well-articulated presentation, because you talked about so many problems and things that are related to this rhetoric speech. You talked about all the problems that we face and all the things that we have to solve. And I think it was super well articulated, and well, I liked it a lot. So I wanted to ask you about one of the studies you talked at the beginning about this, about the emotion in this rhetoric speech. You had a couple of papers about that, and I think. And my question was, do you how do you get recordings of different emotions? How did you elicitate different emotions on the speakers with the rhetoric speakers?
Yeah, that's a really good question. It's a general problem for people working in emotion recognition, and the PhD students spend a lot of time trying to think what would be the best way, and especially two camps: either you elicit the emotions like you're saying, or you find, for example, recordings or videos or films, and you try and guess what emotions they went through. And there are some methods in between. What she ended up with, which I think is a good compromise, is that she took an existing typical speech database, and she replicated their setup so that she had data from an existing, and that's elicited. So that was elicited through showing video clips beforehand, for example, of someone being disappointed, and then trying to ask people to replicate this, and they were allowed to say it a couple of times. But it's very difficult. She recorded some typical speakers as well, so I was one of those, and it is incredibly difficult when you're not an actor. You feel super self-conscious, yeah, I found it difficult. So the lady I showed here, she apologized at the end and said, "I'm just so excited to be in here. I don't think my emotions, I can't really be sad." So it was difficult for all of them to kind of do it well. But I think, as it often is with research, you have to make some decisions. So I think that what she came up with was okay, and we try to validate it as much as possible. But it's absolutely, you're right. It's a tricky thing to get right.
Yeah, it's very interesting. I think
actors out there who, if you are working in typical domain, there are actors you can kind of draw on. But I only know of one dysarthric speech actor. So
Yeah. Okay. Thank you. That was all. Thank you very much.
Thank you, Paolo. I think you can use your micro. Paolo Rosso, are you here?
Yes, I'm here, but I didn't ask
Okay.
anything.
Oh,
didn't
sorry. I
ask,
thought you.
I'm
Okay.
listening. I'm
Okay. It's
listening.
okay.
I'm paying attention. Very interesting talk, but I didn't raise my hand.
I thought you raised your hand. It's okay. It's okay.
Okay. You
Eneko,
go
your
ahead
turn.
than my mind. I didn't think any question.
It's okay. Eneko, can you? Eneko, did you want to talk? Otherwise, we go with Valentin.
Oh, thank you.
Okay. Okay, Valentin.
Yeah,
Yes.
yeah. Thank you, Ima. Thank you very much, Heidi, for your presentation. Just a very couple of short questions. One is about, well, I think these proposals are very challenging, but also very encouraging in the sense that they give you a view of engineering, which is certainly shared by many of us. So as for the difficulty to have enough set of data and how to do, let's say, the transfer learning in the presence of data scarcity, you described pretty well what are your visions and approaches. But I would like to know what are your views about the possibilities of reinforcement learning for this task, in the sense that probably it could be interesting to have a virtual assistant or virtual system beside you and learning from you along your life. So since these people need probably a very highly tailored system, would it be interesting or possible, do you think, to try to experiment on systems related to this reinforced learning approach?
Absolutely, absolutely. I think there are
Or do
different people who have tried something similar. At one point, I was very interested in but it didn't really work out. But I worked with John, the guy on the video, and
oh yeah,
what he does when he dictates his essays is he speaks and his sister will type, and so that you could end up having this nice parallel corpora of this sister's typed transcription. Because of course, a problem, we could ask John to do a lot of reading, but we can't easily transcribe what he said because it's really difficult to understand.
oh yeah.
And yeah, and I think we had a student a while back who tried to work with reinforcement learning in a dialogue system, where you try and predict the accuracy of your kind of recognition, and definitely having a human in a loop would be very interesting. Is that what you meant with reinforcement learning? That sort of
Yeah,
stuff.
well, basically, yeah. As for the scenario, that would be the scenario, one when you have, let's say, collaboration along the time. But second, these systems that just keep on learning as they are used.
Yes. Yeah. I think that's, if at all possible, is what we. So that's what we try to do with home service, and for that we So of course, in operation, you don't know whether you've recognized correctly, and so you're using the ASR label as the correct label, and sometimes you can go back and re-listen. But that's why there is a kind of it's more tricky to do semi-supervised methods where you are not sure about the label. Yeah. So often, if you are recording a typical speech database, you might just have a class of students help you with transcription, but of course that's not possible when you can't understand the speech.
No, and our short experience about that with many laborers is that, you know, our correspondence, let's say, of the results are very poor, especially for these kind of voices, because agreement is not so easy, even for experts.
Yeah. And for the home service, one of the things we were very concerned about was there was an initial phase where we were collecting data and he didn't have a system, or the user didn't have a system. And then, of course, at some point you have to decide, now I put the system into operation, even though you know it's not a perfect system. And to find out when is a good time for that is difficult. Sorry, I've got my ice cream man outside. You might be able to hear. Paolo?
Yeah,
Okay.
I'm a very disciplined attendee, so if Inma wants me to make a question, I will make a question. No problem. No, okay.
I know who's the boss here then.
Yes, Eneko was waiting, but
Yeah, sorry,
he will wait
sorry.
a little bit more.
So actually,
It's
I didn't
okay.
want
No
to
problem. Paolo, go ahead.
I tried just to be nice. And thank you very much for the talk. And so that you focus mainly on people suffering from atypical speech. But if I understood properly, you mentioned talking about, let's say, typical speech, that people suffering from anxiety have memory problems. And so my question is if you at work or if you know also, if also people suffering from, for instance, depression may have somehow also memory problems or other kind of language problems in the sense maybe the usage of a smaller vocabulary. I don't know, something in this direction. Thank you very much.
Thank you. Yeah, that there are, as I said, kind of overlapping symptoms, and it is one of the problems. We are able to, there are specifics for people with dementia that you don't see in people with anxiety and depression. But the problem is often that you have to be an expert to see those differences. And so you have to go and see a neurologist. Whereas if you go to the family doctor, what we in the UK call the GP, they often don't have the expertise to see this difference. And so they have got a patient that is describing lots of symptoms that on the surface sounds like dementia. And so they get referred to the memory clinic. And then it takes a series of tests to really work out that the problem is not. So one of the things we ask about, for example, is when was the last time you had a problem with your memory? And that's why a specific question. If you ask that of someone who's got dementia, they will say, I can't remember, I don't know. If you ask that of someone who's got what's called a functional memory problem, which is often caused by anxiety and depression, they will have very specific, so they'll say, oh, last Wednesday, what happened was I went into such and such and such. So they've got a completely different concept of them. They still have memory problems, but they're more sporadic. So they look quite different, but you need this expertise, I think, to really work this out, how that is. And of course, the hope is that people with these functional memory disorders and anxiety and depression, it's a temporary thing and they might recover. Whereas, of course, if you've got dementia, you don't. So they need completely different treatment and looking after. And the hope is that with a system like Cognospeak, they could be offered this straight away rather than waiting maybe 6 months before they can be seen at the memory clinic, because that's a very worrying time if you already are anxious. So that's the kind of main hope, yeah.
Okay, thank you very much.
Thank you.
Eneko, do you want to make a question?
Yes.
Do you have any? Okay.
Yes, okay. Sorry, I had a problem with the mic. So Heidi, thanks for a great presentation. I have a question regarding your work on speech recognition for dystropia patients. And you mentioned that you could not use that you have a problem with the amount of data because you could not use all the recordings of other patients with this disease. So I was wondering whether, because of this lack of data to train the speech recognizers, whether you could deploy the system and use the feedback from the own users, which I imagine that when they use the system, sometimes they will say, they will feel they will like the transcription, so they are okay, but some other times they don't. So could you use this feedback possibly to improve the system?
Yeah, I think we haven't actually had a dysarthric ASR system apart from the old home service system that were actually working with users, but I think that would be a very nice way to go. Perhaps them having a way of fixing some of the transcriptions if they really see there are problems. So you get that. It's a bit like the previous suggestion as well. So you get that kind of human in the loop kind of. And I think over time you would get a model that would work really well for that person. I think another thing that you would want to learn is, of course, their specific phrases and have a language model that is really tuned to them, because they will each pick words that work specifically well for them. So they've all got words that they try and avoid because they've got different things they can't express or pronounce very well. And so they'll pick particular words that work well for them. And of course, a language model should really pick up on this and over time learn this.
Okay, thanks.
So, are you finished, Eneko? Yes. Okay. Okay. So I have also a question. I don't resist to have your opinion on a problem that we find usually at the lab, which is as you said, there is a huge variability in the speech. So you need. I think it's necessary to get specific data from the user. I think this is a very generalizing pathological speech or in dysarthric speech, because not all cerebral palsy or all Parkinson, they are all different. So getting data from the user is, I think, key in this work or in this field. And I don't know how is it in UK, but it is being more and more difficult for us to get permission to get the recordings. And so, for example, previous to any recording or any project, we must first describe very well the protocols, very well the amounts of recording that we are going to get. So the experimental setup, also the goals, I mean, it's a lot of work on one hand, and it's also tricky because perhaps you haven't thought about all the possibilities or all for example, perhaps you haven't thought about getting data from the user at home, or going to the home to the user, which is also something that maybe you need to do, to go there to make the setup, the experimental setup. So how do you cope with this? And I would like to have your opinion and your impression in this subject.
Yeah.
Not to feel alone, or I don't know.
No, you're definitely not alone. In fact, I haven't recorded. Well, I recorded home service, that was recording data, and the student that recently recorded emotional dysarthric speech. But apart from that, I haven't managed to record. So I think the ethics is a huge barrier. The other thing that's a big barrier in the UK is getting funding for this type of thing. So the main funding bodies don't think they should be funding data collection. And I think, although I really welcome the big companies moving into this, I think that's going to be problematic, because they're saying, well, why should we fund you to collect this data when Google has got 1 million words or whatever they've got in there? And we know, of course, they can't share it, and they will use it for their purposes, which hopefully will help some users, but it would be nice to have. And there's such a need. I just now, as interspeech area chair, I saw lots of papers from Italy with newly recorded dysarthric speech. So I don't know what they've got there, but they seem to have a good setup and are able to.
But do you think they will share they will be
Yeah,
able
I think
to
they
share?
are. I think they are. In my opinion, or in my experience, general researchers are very happy to share, if at all possible.
For example, we did a database, and with all the conditions we thought that so for us to be able to share
Yeah.
at the end, but finally, when we delivered it took us like 1 year or so to put it available, and finally we are not able to release the database to non-European countries because of the data protection level. Yes, sharing data, it's crazy. And now, for example, we've done a very small project recording this Arctic speech, and we are not sharing. It's a lot easier. I mean, otherwise it would took. So it's so complicated.
We are hoping to be able to share the emotional dysarthric speech database. She has a couple of more publications that we want to do first, but maybe I need to contact you when we get to all the problems.
Well, I don't know if there are any more questions. It's already 10 minutes past 4, so we can finish here. I must share my screen. Just 1 second. Sorry, I have too many screens. I think it's this one. Yes. So thank you very much. Thank you very much, Heidi, for this wonderful and very informative talk. And thank you very much also to all the participants. As you probably know, this is the last talk of this year, this academic year. So we will start again in October, probably. So stay tuned in the webpage, and looking forward to seeing you all in the next webinars next autumn. So again, thank you, Heidi, and see you soon, I hope.
See you soon, yes. Thank you so much, everyone.